Hello, good morning. Let's start with another problem in DSU series, that is closing the farms. So this is the problem like farm John and his cow are planning to leave the town for a long vacation, but FJ want to temporarily close down his farm to save money in the meanwhile. Okay, so John and his cow are leaving, and so he want to close some farms to save some money. So we have some farms. Okay. The farm consists of n barns con- connected with m bidirectional path between some pair of barns. Okay. There's n barns and m bidirectional path between barns. Okay. To shut the farm, FJ plan to close one farm at a time. Okay. So close in order to close farm, he is going to close farms one by one, and they are in barns. So when a barn is closed, all the path adjacent to that barn is also closed. Okay. So one by one, we are going to close a barn. Now, all the edges which are going from that barn to other barns are going to be closed. Okay. Can no longer be used. Okay. FJ is interesting in knowing at each point of time, initially and after each closing, whether his farm is fully connected, meaning that it is possible to travel from any open barn to any other open barn along the appropriate series of paths. Okay, so FJ is going to close some barn, and there will be remaining some active barns, and we want to check whether those active barns are fully connected or not. Okay, okay, now next. Since FJ farm is initially somewhat in a state of disrepair, it may not even start out fully connected. Okay, so since F initial farms which are given as n node and bidirectional node may not be fully connected. Okay, and we need to calculate answer for initial answer also. So for first, we need to check whether all the farms are fully connected or not. Okay, let's go through the input format. First, we are given input consists of n and m. So first we are given n and m, that is number of node and number of edges. Next M line each describing a path in terms of pair of bonds it connect. Bonds are conventionally numbered 1 to n. Okay, so next M lines we are given edges of nodes. So they are M edges. Okay. Next N line given a permutation of 1 to n describing order in which bonds will be closed. So there is given a permutation of 1 to n. They're describing the no order in which bonds is going to be closed. Okay. Output format, output consists of n line. Okay, each line containing yes or no. Okay, the first line indicating whether the initial farm is fully connected. Okay, so first answer is going to be check for initial graph. Next, I plus 1 indicating whether farm is fully connected after I closing. So after each closing we need to check whether graph is fully connected or not. So now we are understood the problem. Let's go through the sample input and try to understand the problem. So you are giving four nodes and m edges. Four node, that is 1, 2, 3, 4, and m edges. First edge is 1 and 2. It is 1 and 2 is connected. Then 2 and 3. 2 and 3 is connected. Then 3 and 4. 3 and 4 is connected. Now next we are given a permutation from 1 to 4. And each time we are going to remove one node and all the edges which are connected with an active node. And after each removing edges, we are going to check whether all the active nodes are fully connected or not. Okay, and we are need to print in answers. Initially we need to check initial graph whether it is fully connected or not, as we can see that all the nodes are connected by a path, and we can travel from one node to any other node by the edge connecting those nodes. So initial answer is going to be yes. Let's go through the queries which we need to process. So firstly we're going to remove the 3 barn. So node 3 is going to be removed, and all the edges which are pointing to active node are going to be removed. as 3 is pointing to 2, 3 and 2. This is going to be removed. And 3 is pointing to 4, 3, 4, and this edge is going to be removed. Now after this removal, we need to check whether all the active nodes are connected or not. As we can see that 1 and 4 is not connected, as there is no path we can travel from 1 to 4. Similarly for 2, but from 1 and 2 we can travel to each other, as all the active are not fully connected. Next answer is going to be no. Now next we going to process next query, that is 4. Now 4 is going to be removed from the graph, and all the edges which are connected to active node. As there is no edge, there is nothing need to be removed, and we are only remaining with the node 1 and 2, as the two nodes are connected with an edge and we can travel from one node to another. And for this, answer is going to be S. Next we are going to remove node 1. So this one is going to be removed, and all the edges which are connected with an active node is going to be removed. So 1 is connected with 2, this edge is going to be removed. Now we are remaining with one node, that is 2, and it is fully connected. As from 2 we can go to 2. So for this, answer is going to be S. So this is the only answer we need to calculate. S no S S. S no S S. So this is the problem we need to solve. So let's go through the logic how we are going to solve this. Okay. Okay. Suppose, so what, for this we need some data structure, that is known as DSU. DSU we already go through it, that is provide two functions, that is find for u, going to remove return parent for u, and there is another, that is merge, that is going to merge u and v into one component. And the problem I have covered before this problem, we have already see a variable c that that return number of component in current current tree. So we are going to have number of disconnected component, and while merging we are merging those component, and this c is representing number of current disconnected component we are currently in DSU. Okay, so we are going to use this c variable, and we will create a method that is going to return this c in current DSU. So when we used to create initially used to create DSU, then initially all the nodes are all the nodes are as all the nodes are single. So initially all the nodes will be individual nodes. So initially all the nodes will be individual nodes. So DSU initially all the nodes are individual nodes. Okay. So, okay. So for this problem, we are going to process the query from last to bottom. So first we will process 2 and 1, then 4 and 3. And apart from this, we going to maintain an active nodes array. So this active nodes will represent how many nodes which are currently in DSU are that is active, and we need to check whether that active nodes are fully connected or not. On that basis, we are going to calculate the answer. Initially, all the queries have already been processed from top to bottom, so all the nodes going to be non-active. So all the nodes are non-active. Non-active. So now we are going to process queries from last to bottom. So first we are going to process 2 and we're going to make this node as active. Okay. Now 2 is become active. As before 2 we need to calculate the answer, as 2 is the only node which is fully connected. For this we are just for going to call C. C, as C is going to be for DSU, if we calculate C, C is going to be 1 2 3 4. As per our assumption, these nodes are not active, which we have stored in active node. But as per DSU, the all the nodes are present in tree. So this is DSU is going to return 4, and this 3 can be break down as 3 plus 1. 3 representing number of non-active nodes. And how we are going to break this, as we are processing this input and we are remaining with 3 that need to be processed. So this 3 is representing non-active node, that is 1 4 and 3, and we are remaining with 1. This 1 is representing that all the active nodes are fully connected, and this is the non-active node that are individual node that are not currently in active graphs. So as this is 1, so answer is going to be S, as this is the fully connected node. If you are not able to get this, let's move to the second input, then I hope you will able to get it. Okay, now next move to 1. Next move to 1. Now we are going to make 1 as active. Okay, now next make 1 as active. Okay, now make 1 as active. Now 1 become active, and we are going to add all the edges which are pointing on the active node. As 1 is pointing to 2, we are going to add this edge, as it is pointing to active node. And while adding this edge, we are going to call merge function of DSU. This is merge function. So this merge is going to call, and this component is going to be merged, and this node going to be an individual node. After this, we are going to calculate C. So now C is going to be 3. So number of component fully connected component in current DSU is 3. That is these two individual node and this merged component. And this 3 can be break down into 2 and 1. Here 2 is representing number of non-active node. This can 2 can be find non-processed queries, that is remaining 2 queries. And after this is the only one, as this is 1. So now whatever node which are currently active is fully connected as one component. So for this, answer is going to be S. Okay. Now next move to the next query, that is 4. That is 4. Now 4 is going to be processed. Now make 4 as active. Now make 4 as active. Now 4 become active, and 4 is pointing to 3. But 3 is not active, so we not need to add the H. Okay. Now we are going to calculate C for this graph, as C is going to be this component and this component and this component, that is 3. As for this, as edge is pointing to 3 but 3 is not active, we can't add an edge and we cannot call the merge function. So now C is again going to be 3. Now we need to break this, as we are remaining with only one query, that is 1, and we are remaining with 2. So 1 represents number of non-active edges, and this is the number of component we have in current active nodes. So we have 2 component, and that is not fully connected. So for this, answer is going to be no. So now you understood this part. So when this part is 1, that is representing that 1 representing that whatever active node we currently have, that is fully connected. As this part become greater than 1, then there are more than one component with active nodes. And this non-active node, that is individual active node, so they're obviously not going to be connected. Okay, now next move to the next query. Now we are going to make 3 as active. Now 3 is going to become active. Now 3 is become active. 3 is connected with 4. As 4 is active, that this is need to be added and merge need to be called for 3 and 4. When 3 and 4 merge is called, then these going to be merged into same component. Next edge is 3 and 2. When 3 is 2 is no edge is added, then merge is called for this, and this edge is added, and both these components going to merge. Now we are going to calculate C. Now C is going to be 1, as there is only one component, and when we are going to break this, there is only no queries remaining, so it's going to be close 0 and plus 1. So here 0 is non-active edges, as currently there is no non-active edge, so it's going to be 0, and we are remaining with this one. This one is representing that we are having only one component with active edges. So if there is only one component, then all the nodes going to be fully connected. So for this, answer is going to be S. Okay, so this is the process we need to follow, and we are going to use this DSU, and this C we have already covered in previous videos, so I think you need to go through that video. And this active node array is needed, as we are going to travel across edges. We need to check whether second node is active or not. uh, Apart from this, if we can maintain a set and check whether this query is processed or not. So while we are processing from bottom to right, we are going to update this active node to check whether this is active or not. So let's go through code, so get it better understanding. So first, we are taking n and m, that is number of nodes and edges. Next we are going to form the graph, which next we will need it when we are going to add edges or going to merge. So u and v and g of u and v. Next we are taking the permutation of 1 to n, that is number of queries which we need to process, that is qi. Next, we are creating DSU of n. That is DSU of n, that is individual. Currently, we have individual nodes. As DSU is currently we have not called merge function. Next, we have an active array, that is representing number of active node currently have in that. Next, we are storing bool answer. This is the answer which we need to print. As we are calculating answer from last to bottom, we need to store it, and after that we will print it. So for this, now we are traveling from last query to first query, and q of ui representing here last query. So for this, we are calculating across it edges, and if now qi is pointing to ch, if ch is active. So let's see, when we make 3 as active, and we are checking whether 3 is pointing to 4, and we checking whether 4 is active or not. If it is active, then we are going to add an there is no need to add an edge, but we are calling the merge, so we need to merge this and this. Okay? Okay? And similarly, we will check whether 2 is active or not. If it is not active, there is no need to call merge. Okay. Now next, move to, we are predicting C. If C is I, then answer is going to be S. Here C is I, is that is that I minus 1, that is I minus 1 queries that need to be processed, and that is 1. So 1 representing number of component component with activities. So it's going to be 1. So I minus 1 plus 1 plus I. So count must be I, and I representing I minus 1, that query that need to be processed, non-active edges, plus 1, that is whatever tree we have, the connected component should be 1. If it is I, then answer is 1, else no. So this is the now we are making this node as active for next queries. So yes, initially this 4 was not active, and while we are traveling we making this active. So when we going to process next time, so this edge can be active, as we make 2 as active, then while we are processing 3, then this edge can be added as not 2 will become active. Okay, as answer we have processed from last to bottom, we need to reverse the answer and just print it. So I hope this makes you clear. If you have any doubts, please leave a comment, and I hope